have an agenda. We just had, it's a pretty brief meeting tonight. It's Parrot Tailings Waste Removal Project update by Jim Ford. Parrot Groundwater Monitoring Plan update by Josh Vincent. And then I'll go over the latest Butte Area 1 Restoration Fund numbers. And after any presentation, we have time for questions. No action items tonight. One thing I wanted to start with is I've had 100 questions about what did you guys plant? Because I mean, if you drive down Shields Avenue or anywhere around here, you see that stuff and it looks like you're in the middle of Kansas. And it was a seed mix that was recommended by Robert Pell, the restoration ecologist from Montana Tech. And in that seed mix, he spec'd out triticale. What triticale is, it's a hybrid between rye and wheat, and its seeds are actually sterile. So this is just a cover crop that will provide cover to the grasses that are growing underneath. That the native grasses will actually be the cover that will be there after this year. So that triticale will be back next year. And the purple flowers, that's a Rocky Mountain bee plant. But I'm just gonna pass around some triticale. And since it's half wheat, half rye, I thought it would make a perfect swirl rye bread. So maybe we'll try that after. So our first speaker is Jim Ford. And sorry, we don't have a remote, so you gotta advance yourself. So.
Okay, so I'll be pretty quick. I don't really have a lot to say. I'll give you an update on where we're at, and then later on, after Josh presents our PMP data, our performance monitoring plan, groundwater data for the last couple of years, I'll talk a little bit about where we're at in the budget, and then I'll give a little bit of an update about where we are on any future activities for the Parrot, i.e. primarily talking about the possibilities of any additional groundwater capture and what we're doing going forward. But currently, as you can see, we don't have the south parking lot paved. The subcontractor's supposed to be in first thing tomorrow morning. I think that's a 3 or 4 day activity, 2-day activity. So we'll get that paved. There's some cleanup actions after that, just a little markup, and then I think we'll be working with Butte Silverbow to reopen Civic Center Drive. The contract end date is at the end of the month, so all the non-punch list items will be completed before then, but we're hoping to get the road open and everything else, much sooner than that. Aside from that, any questions? I guess that's the short of the long. All right, so again, we got Josh Vincent of Water Environmental Technology. He's going to give us an overview of the PMP data review for the last 2 years. Now, remember, we did a review with our conceptual site model. Elizabeth did a couple of years ago. So this is sort of an update and revision on that. And again, remember, we have a very extensive monitoring network, almost 100 monitoring points, 80 some of which I think are wells. We've got subterranean points and some surface water points. But Josh is going to give us an overview of the analysis of that data and what we've seen. So this is the primary data that what we've seen since we started implementing the project in 2018. So I think hopefully he's got some pretty, I would call it exciting in a hydrogeologic sense, maybe. Not so exciting for the rest. Review. I was going to sit here so I could. Yeah, you might have to sit.
Look at that.
Right there. There we go. Does that work?
I don't know if it works, but.
I think it does.
I'm pretty loud.
Yeah, you are.
Is it this one?
That's the thing.
Again, CSM November?
For the construction. That one. Did you want to show me the photo or not?
Yeah, why don't you click on the photos? Do the photos first. I can flip through those. Oh, okay. There's, wait, it's got all fun minutes.
I'm not a participant like too, if you wanna do anything.
Let's see. This is it, right? Yeah. This one. You could scan share, so just. Oh, I know, but there it was. Hey, so. Here.
We've got a couple, we flew, as most of you know that have seen these presentations, we flew the drone a bunch. And the drone, the interesting thing about some of the oblique angle drone shots are that you can fly it to the exact same location and orientation. And so we can look at the site over time, from up high in an oblique angle. Yeah, sure. So we'll just run through these really quickly. I'll just point out a couple different things. But I think they're pretty telling over side. So again, this red outline is our excavation area. We removed all the waste, but that's not the whole project area, right? We have a whole 18-acre area back here that received a 36-inch evapotranspiration cover, right? Which was to interrupt infiltration through the waste down to groundwater. The waste back here were inaccessible because of infrastructure, but they were above groundwater. So they weren't sitting in groundwater, and the pathway to groundwater contamination was infiltration. These wastes in here were primarily sitting in groundwater, and the only way you can address that is for removal. So these are just the historic pictures of the Parrot. We've seen these a bunch. That's the confluence area. So this is where DEQ is doing their cleanup here going forward. You can see upper Silverbow Creek and the nice water quality discharge in there into Blacktail Creek. Okay, so here we go. On March of 2021, this is before we demoed the shop. So this is phase 2, Civic Center Road. Here we're back here in the annex of the Civic Center, but the shops are still standing. We've got the shops completed and reconstructed there on Beeftail Road. Okay, now the shops are down. Most of the demo debris is being hauled away. We have some tank removals and such. Okay, most of the infrastructure is stripped out, asphalt's out, everything's out. And you'll see here going forward how we did the actual excavation. People have a misperception about how you develop these sites, and they think that, it's maybe one big hole all at once, but that's actually not how it goes. That's not how you dewater waste. That's not how you remove waste. So again, here we are in the early part of the summer. Getting later. Now here's the first cell. So you dewater and excavate in cells. You don't try to dewater the whole site. It wouldn't be possible. You do it in cells. And what you can see here, which is interesting, we've got a clean overburden. So this is primarily cap rock from the Berkeley pit. But you can see the tailings here are their finer grade tan material that has been reworked multiple times. And right below that is the black organic peat that was the highest concentration of all the materials, because all this stuff leached down in there. That's what we are primarily looking at removing. So you can see those 3 layers. We removed down below that peat layer. And if we were still exceeding our waste criteria, we excavated to groundwater. If we were already below groundwater and we removed the peat, then we'd stop. So again, take the clean fill off here, dump it in the old hole, and then excavate the waste again. So you're flip-flopping, so you're not double handling materials. But to do it like this, what is critical, and what we developed with WET was a protocol for constantly sampling and quantifying the quality and the types of these materials. So that's sort of critical, because we can't guess where all these compacts are. There's no way you can model it. If you tried to sample it, it would take you know, probably hundreds, if not 1,000 samples, and you would still be off, right? And after spending probably a few $1 million sampling. So our concept going into the project was we'd get enough data to bid the project. We would construct the bid package that allowed variabilities of materials, and we would determine that on site with an XRF. Again, here's a next cell, again, excavating waste, taking clean overburden, flopping it in to the excavated cell. More, here's a cell down here. Center, now we're getting into the winter, almost turn of the new year, but we worked through the winter. Again, here's some cleaner fill. I think actually this fill maybe came from Montana Resources. We ran a little short on our expectations on fill here. So we ended up having to find another 170,000 cubic yards at Montana Resources. So we'd run our trucks up there, our 50 to 70 ton trucks up to MR with waste in them. Then we would fill them, dump the waste, fill them with clean fill and bring it back down here for efficiency purposes. And that's all Montana Resources fill.
That's ET.
ET here?
Yeah.
Okay.
It's MR underneath, but that's stockpile to go.
That's a stockpile of ET cover. So that, again, that came off of the Eulens Ranch out there at Rocker or across from Rocker. And it took us a couple of years to find the specific material. It had very specific specs because you want it to hold water from infiltration, so it doesn't infiltrate through the waste, but you also want it to release water to plants to get evaporated and transpirated out in the spring and summer. So it's very specific and for types of material, and we couldn't find it anywhere in the Butte Valley. Again, just more cutting and fill. You know, here we are in the spring, early summer. Now we're putting our soil cover on top of this material. And then, you know, revegetation of it. That's sort of how it looks.
And there's a series of just overhead too. If you
Yeah, so just go through this really quick. So one of the things I want to point out, here's all that poured slag. Again, we constructed this area, the sliver, this whole area, and this area up here all received that 36-inch evapotranspiration cover. In 2021, you can just see how the site, the roads out, how the excavation, storage, and management of the materials, which is critical for cost-effective implementation of these projects, is simplifying and reducing the times and types of where you manage the material. And as big as this site seems, it was actually for the amounts of material that we were handling, it was a pretty tight area. Again, over here, so this is all the trailers that were associated with that TV show. So we finished out this component, or Dale did, ICS did. So it allowed them to expand and move all their trailers into that parking area on the north side. That's completed. You can see we're starting to construct the ET cover. We still have the haul road in here, you know, in April. May. You can see the haul road's been out. Now we revegetated stuff. So the vegetation you see out here in the south excavation in the middle, this stuff's just temporary. It's 18 inches. It's a temporary vegetative cap. And Butte Silverbow is going to decide what to do with those two parcels. These areas here are the 36-inch ET cover. And then we have some slivers here of also permanent vegetation on this berm and over here on the north side on that slope of the railroad. Those are permanent, but you see we got the new Civic Center drive-in, and of course this meets all the modern specs, has parking adjacent, has utilities under it, and has the sidewalks, all of which, you know, didn't have before.
So that's plus.
So that's it.
Yep.
All right, so Josh, you're next.
Oh, yeah. Where's this? Help me get this.
Hey, Jim.
Yeah.
Just one question about the temporary vegetative cover. So Butte Silverbow.
You guys take the mic, otherwise the people online don't hear you.
So my question is that, so there's a temporary vegetative cover on the areas that you just showed. And that Butte Silverbow is going to come back in and put more vegetation in, or did I misunderstand that, or?
Yeah. Yeah, we're, you know, our agreement with Butte Silver Bow is just how the site is completed now. Butte Silver Bow is gonna decide what they do with those. They call them, I think actually in the agreement, it's called developmental parcels or something.
Okay,
So I don't know, you know, they're gonna go through the land, you know,
yeah, use.
land use processes to figure out exactly. What we agreed is that we were gonna have a temporary cover. Now, the good thing, because we removed all the waste, is there's really shouldn't be any prohibitions on how you can use that land, right? Because it doesn't have any waste. You don't have to worry about infiltration or stormwater stuff. I know there's other considerations with groundwater in the alluvial system as a whole, but for the site, there's not limitations. But it's Butte Silver Bow's property. We agreed to vegetate those areas, an interim vegetation, and they'll decide long-term what they do. But you could put more vegetation, you could develop them for a hotel. There's lots of things you could do here, but that's Butte Silver Bow's deal.
Okay, thanks.
Any more questions on Jim stuff before we move on?
I'll just run.
Yeah, all right, well, let's go through some of the recent groundwater data. So, as Jim said, we put this PMP plan together before we started the phase 1 excavation. So we started this in late 2017, early 18, because we wanted to get 4 quarters of data before we started doing removal activities, and then wanted to continue to monitor it through. So, and then we did the conceptual site model report in 2020, which summarized data through 2019. So it really just showed the preliminary or the phase 1 data. And so this addendum really covers the last 2 years, which gets us from 21, 22 through it, and we're still monitoring through 23. So through this second phase. So I'm going to keep this pretty high level. There's some graphs, and in this environment, I don't know how well you're going to be able to see them. So I can just keep skipping through if you can. I was just using the arrows.
Yeah.
Gonna be real high.
Super high level.
I'm not sure we have the right. Sorry, let me, okay. Sorry. I'm gonna we got a bunch open. All right, so hopefully this will be it.
Okay, take 2. Okay, just real quickly. So this was Parrot project goals, which we've been over that, but really protect the creeks from contamination, eliminate basically the largest known source of contamination in the BAO corridor, and enhance the riparian areas. So we can skip through some of the background. Really 2 reasons why we wanted to put this PMP program together. One was to basically track performance of the removal, right? So we want to see how the system reacts after we get done. And then also just to ensure that we weren't having impacts on the existing circular remedy infrastructure, i.e. the Silver Creek subdrain. So, and we're seeing some things in subdrain that are pretty interesting that we'll point out. So, go ahead, Jim. So just reminding everybody, Jim put this slide together a long time ago. The Parrot, it's a groundwater problem, right? I mean, it's tailings in groundwater that are migrating down valley and into surface water. And so that was the why we needed to remove it. Elizabeth alluded to preliminary studies saying it was going to take 100 years for contamination to get to the creek. So it doesn't take very long at all. And then our data backs that up. Bureau data, everybody's data is showing that. So go ahead. So again, the PMP network, it's shrunk a little bit because within the footprint of the removal, we had to abandon some wells to be able to do our tailings excavation and build our caps. So right now there's about 63 wells, 5 surface water locations, and 3, we split samples, 3 subdrain manholes. Again, I already kind of talked about the original draft. The original report had data through 19. And then from 20 to 22, we're doing monthly water levels and quarterly sample events on this network. So we took a transect approach. This is a Nick Tucci laid out system here. So thanks, Nick. Basically, we are monitoring transects perpendicular to groundwater. So groundwater flows from the Parrot towards the creeks. And so we basically are slicing across the aquifers to do our monitoring. And there are 3 aquifer units in the BAO system. There's the upper alluvial, the middle, and the lower. And so we were able to get data from all 3 of these and have been collecting it for now going on 6 years. So this is just a quick rundown. You may not make too much sense of it, but this just shows the wells and what aquifer unit they're in by transect. So A is mostly upper, which is it's basically just up gradient of the Parrot. So the A transect sort of cuts right through the railroad Shields Avenue. So then B is immediately down gradient. So it's basically right at roughly Harrison Avenue. So you can see we've got upper, middle, and lower data wells there. And then we sample a manhole there. And then transect C is right at Casey Street. D is sort of down by Caw, and E then is right at the creek. So anyway, that's just a rough. And this is a mix of existing wells that are being monitored through Remedy, and then we installed about 25 new wells that were kind of filling some key data gaps that we wanted to collect data from. Most importantly, right next to the subdrain, there were not a lot of wells right next to the subdrain, so we were able to look at, how good that was collecting groundwater. It does collect groundwater, but it doesn't collect it all. So our little addendum, really, this is just a tech memo follow-up from our original CSM. We're just running through. I am going to spend a little time talking about our interim dewatering system data, which is really awesome to look at. We looked at elevation data. We just looked at quality data, and then have a few conclusions and recommendations. So go ahead. So this interim dewatering system sort of was hashed. It was an idea hashed by our team. We had to do the phase 1 north of Civic Center Road, and then we had to wait while Butte built their new shops. Couldn't move out there overnight. So there was this 1.5 year period of time when we had to kind of wait around, and we were balancing fill between the 2 sites. And so the north side was low, and it was only about 10 feet of groundwater. And when we excavated the first phase, the blue water was not just in the one well, it was everywhere. So we're like, hey, let's slap a little shallow collection system in here. We had a sump that we had in there for dewatering, and let's hook it up and let's pump it. We had a part of the Montana Resources Agreement allowed us to send dewater water to the mine, and it was a 5-year agreement. So it was really a low bar. I think it cost us about $170,000 to put that in. And I'll show you, it was really, it had huge benefit to the system. And I think we should continue to look at operating it until stuff starts to clean up. So we operated it seasonally in 19 and 20. And then in 21, after we bid this out, we handed the keys to ICS and said, you can use this for your construction dewatering. So basically it saved the project money for him trying to come up with how to dewater the system. And he ran it continuously for basically 2 years, all of 21 and 22 until he was done excavating waste and he didn't have to dewater anymore. So anyway, go ahead, next slide. And I'm sorry, this is kind of hard to see, but this is basically the monthly volumes of water. This is 19, 20, and then 21, 22 cumulative volume. But, you know, we converted the concentrations to mass, and just kind of to read you on some of these. So, you know, we removed over 35,000 pounds of copper, 36,000 pounds of zinc, 600,000 pounds of sulfate. I mean, big numbers. This is just one. So we sampled the discharge monthly during construction and during operation. This is copper. It's kind of hard to see, but basically this line, this is about 100 to 200,000 ppm, 150,000 ppm. And what you see is it really, the concentrations have stayed high over a long period of time. We pump this thing anywhere from 20 to 80 gallons a minute. But big concentrations. pHs have still remained below 4. So this is a secondary source right in the core of the plume. So really big recovery and big removal here. So go ahead. Okay, jumping to the elevation data. As I said, we collect monthly levels from our whole network. We also have some transducers in about 30 wells. And what we saw here in the last 2 years is, as this dewatering system was pumped more continuously, is the groundwater, the dewater cone started to spread from right around the site to, you know, we were seeing basically right upgradient of the Parrot, almost as much as 8 feet of drawdown, 3 to 5 in B, right at Harrison, a couple of feet all the way down at Casey. So really, it just shows you how connected the system is, right? It took 1.5 years to see those impacts quite a ways off. And we were really only pumping the top 10 feet, just the upper alluvial. So system's connected. So anyway, and then it did start to trail off down at D and E because you've got the creeks coming in there. There's a lot more going on there, and you lose the impact concentrations are lower. So so that was the big groundwater data. I think I threw a few graphs in here. Jim, go ahead. So AM8, that's up on the A transect, but you can see here that's 654.64 to 56. So this is 8 feet of drawdown right here, right? And 1A is down on the B transect, I think, and it's 4 feet of drawdown. So these are big drops. Go ahead to the next one. And then you still see downward trends in a lot of them, but when you get down into the D, these are, if you look at the scale here, I apologize, they're hard to see, but these are like less than a foot of drawdown. So they're tenths of feet instead of feet, but there's still impact there. So, all right, let's go ahead. Let's get to the data. So again, sort of the non-metal data, and I'm doing a pretty high level summary here. Very high sulfate TDS, which you would expect in the plume. Very low pHs, 3 to 4 within the core of the plume, and then you do see it start coming up as you get down to the C and D transects. It goes up into 6 to 7. We did see there's a little hot spot around Columbus Plaza. I think there's a different additional source area there that we're seeing in some of the data. So all of the water quality parameters elevated. And then we did look at some rare earth metals, and there are 3 of them here. I am not going to try to pronounce those. Nick, you might be able to, or Gary, but they're in the Parrot plume and they dissipate downstream. So we're seeing it. It's a tracer for Parrot plume water. So, and then the metals. So I sort of talked you through the 5 transects again, so I'm not going to do that again, but I have one slide on each transect, and I'm just going to call out a few things so you can see what's going on here. So go ahead to the next slide. So AA prime. So again, here here's sort of a snapshot. So here's roughly where that transect is. You can see it, it's right at Shields Avenue. And what we did is we took all the wells in that transect and we did a statistical analysis on them for copper, sulfate, zinc, conductivity, and pH. And then we sort of noted whether there was a statistically significant trend, yes or no. And then if there was it increasing or decreasing, right? So that's the simplest way to just figure out what's going on here. So not that there wasn't a significant trend for every parameter on every well, but what I will say is that the A transect, which is, this plume it runs up into here, but was 100% decreasing trend in the A transect. Every single trend was down. And, here's just some rough, this is AMW 8, which is right here, and there, that's zinc, that's copper, big decreases, kind of on this upgraded edge of the plume. So, and then 40R, this is actually a middle alluvial well. So this is sort of over, kind of right here, over by Texas Avenue there. And we're seeing some pretty good drops in middle alluvial well up there too. So go ahead to B, Jim. So again, here's the B transect. It's right at the Civic Center and Harrison Avenue. So what you see here, 1A, so these wells that are sort of at the distant edges are seeing big drops. 1A is great. And the reason why 1A is great is because it's right here. And keep in mind the timing of this. We removed phase 1 in 18, and groundwater's flowing here. So really 1A is a little bit cross gradient from the phase 2 area, which we had not excavated yet. So we saw some really good drops coming right there. And then we're seeing some here too, because when we did this, Elizabeth astutely pointed out that there's a little component of flow that's running out, missing the subdrain and hitting Blacktail Creek. And so we're seeing, and you see it on this sort of the southern edge, all of these southern edge wells are dropping pretty significantly. So, and again, as far as the trend summaries go, again, almost all of these are not 100% decreasing, but most of them are decreasing. The plume's still pretty hot in here, and some of this data ended in 22, and we finished our removal in 22. So there really hasn't been enough time to see a lot going on, especially in the really highly contaminated stuff. But all of the edge wells are showing some serious changes. So let's look at C. So C is kind of mid. This is Casey Street crossing right there. We are still seeing some reductions, although it gets a little muddier here. A few, there's a lot going on in here. Not every single well is decreasing. I mean, to be honest, there are still some that are wowing around a little bit. But I highlighted this is the subdrain manhole. So right on the subdrain manhole, basically all statistically decreasing trends in the subdrain. So that's picking up groundwater and it's cleaning up. So that's good to see. I threw this one in here. This is actually a lower alluvial well, and it's showing a little bit of drop too, not super significant, but we're seeing impacts in all three aquifer units. So going down then to D. So D's right at CAW, and again, so you start to see less statistically significant trends. There's a lot of noise going on here, but again, we sampled a manhole right on the subdrain, and this one's great because copper, sulfate, zinc, conductivity, all decreasing, pH increasing, which you want to see pH increasing because then you're cleaning up. So, but still we're seeing some positive impact there, but D and E get a little bit less clear, I guess. So quick look at E. Again, you're seeing, and these concentrations are quite a bit lower too, so it's a little bit harder to see the trends. So, but E's right along the creek here. So go ahead. There's a summary slide here, Jim. So again, in A, 100% of the trends were decreasing. B, about 60% of the wells showed a trend, but almost all of them were decreasing except for maybe one well. And then C, we saw, trends in all of them, and C is really about the down gradient edge of the main plume. So you would expect you excavate out the source of this, the plume's going to start to retract. So you see it good there. And then D and E, less percentage of trends, but still like sulfate and conductivity, they're all reducing. So for early in the game, it looks really good. So anyway, so really simple conclusions. The IDW system worked really well. Removed a ton of really highly contaminated groundwater. Our perimeter plume, the perimeter of the plume is showing some big movement in all of the aquifer units. The core still pretty hot. The other thing we need to do is we need to get some wells replaced in the middle of that plume to kind of see what's going on, because we had to tear all of those out during construction. So we did see the rare earths in the Parrot plume. And then there is something going on at Columbus Plaza here, which hopefully will get addressed as part of this, part of the remedy that's on the docket. So, and then recommendations too. This system, because of how highly contaminated the groundwater is, and then it's remained that way with some pretty, really we put it in as sort of an interim measure, but it could be expanded and probably should be expanded. And you put vertical wells in, you catch all the aquifer units, pump it at a higher rate, and you will clean this plume up a lot faster. And I mean, it would require Montana Resources to continue to take the water. They take the water and just put it in their system, and they don't even know it's there. It doesn't cost a dime. So Mark's right when he says the big mine can be an asset on things like this. So we need to go back in and replace some of those source area wells that were taken out during removal. And then, Jim was going to talk about this a little bit. We do need to continue to monitor in some fashion. It's probably time to reevaluate it and maybe try to winnow it down, because monitoring all these wells for this period of time is not cheap. And so, Jim, I don't know if you want to cover these last couple of slides.
Yeah, sure. Thanks. Thanks, Josh. So it's always nice to listen to an engineer get excited about how to geology. So I'm pretty happy about that. It made my day. Yeah, so I want to talk a little bit about the PMP network again. The PMP stands for Performance Monitoring Plan, and it had two purposes, like Josh said. So there was the purpose, we want to look at effectiveness of the remedy, right? But the real purpose was that we have some liability that's in the consent decree that came into the consent decree after we started the project that we wanted to make sure that we addressed, make sure the state's liability was protected. And that's for impacts, as Josh mentioned, to not only subdrain, but any other sort of remedy infrastructure by BP. So it served really two purposes. Now that we're done with the project, we haven't seen any negative impacts to the subdrain. We've seen positive impacts by reduced concentrations, but we're going to need to reevaluate the purposes and goals of the PMP, because it's an expensive component. It's running about $500,000. Our total costs are about $500,000 a year. So we're a couple $1 million into this. Again, this was not budgeted as part of our original $36 million budget, because when we came up with that budget, it wasn't necessary. But right now we want to look at what we need to do. I think, as we've discussed at the BNRC before, we want to try to work with BP. They're doing a lot of groundwater modeling, and I think there's a real opportunity here to stack our monitoring needs. They're monitoring a lot of the same wells. The only wells they're not monitoring are the wells that we install. So if we can stack that and they collect the data that we also need, that will reduce the burden of those costs on us. We can still individually analyze the data, but at least we wouldn't have to be paid for sort of redundant collection of the data. So we had a meeting on it the other day. I think Doug, who's going to be the interim director going forward until we find a replacement for Harley, where he's gonna reach out to some management at BP to see if we can sort of kickstart that, because on staff level, it's sort of come to a standstill. This is a figure I've showed you before. I'm not gonna spend a lot of time on it, but this is where sort of discussions with BP and EPA staff ended. What you can see in here, and they were sort of hard, is you can see this interim dewatering system. And again, these are French drains, right? These are like the subdrain. They're horizontal slotted drain pipe wrapped in geotextile and some gravel down there, right? And we're collecting it horizontally. But the real way you collect contaminated groundwater is through vertical penetrations, through wells, right? Because then you can vary your pumping, you can vary the cones of depression and the capture efficiency. We don't really have control of this system. That's one of the problems with these systems. When water reaches that elevation, we can't make it go lower. We can make it go higher by turning it off. And so what we calculated in here, these light red dots, I mean, there's a lot going on here, were 1, 2, 3, 4, 5 pumping wells, all manifolded together, discharging again up at MR. And then these blue dotted circles you see here are the capture zones for those wells. So we think we could capture the contamination in the parent spot with 5 wells, pumping at a total rate of somewhere less than 200 gallons per minute. So this is the concept we've been talking about with BP and EPA. We run through, as we've discussed before, all the advantages we see for their infrastructure, reduced flow in the subdrain, reduced concentrations. We know the subdrain continues to clog with the metals. So if we get the biggest metal source out of it and increase the pH, that will really reduce their operation and maintenance costs, not only of the subdrain, but for all the water they collect there that has to go to the BTL. So I think the next one's just the cons. Yeah, so this was our estimated cost of it. Pretty concept of that 5 wells manifolded together. I think, this is a couple of years old now, so it was before sort of inflation kicked in. At the time, I think this was a real conservative number because we didn't know, if BP was implementing it, as you all know, we see this contaminated groundwater as BP's responsibility, not the state of Montana's. But we weren't sure if BP would be implementing, or maybe it was something that they would want to pay the state to implement it. And I thought at the time we could do it for substantially less than this. But, again, that was 2 years ago. So even at the time, we're talking about $2.5 million. Okay, this just gives you what we've spent so far in the PMP. We're about $2 million in. And this was what Josh described as the interim dewatering system. Again, it was low hanging fruit, 330,000. I don't want to minimize because I know for most of us, 330,000 is a lot of money. But for removing, 34 million gallons and I don't think it was quite tons of metals in there, but it was thousands of pounds, right? So those are just the costs of the PMP network. And that's it. So we're going to continue. We're going to re-scrutinize the goals and objectives of implementing the PMP. And then we're going to see if we can kickstart discussions with BP and see if we can coordinate efforts. And so that's going to take us a little bit of time, but when we get to make some progress, we'll be back to talk about it. Any questions?
Questions from the council? Anybody on the council? Go ahead, Gordon.
More of a comment. 200,000 people. That's 20% copper. That's pretty impressive. So when you're processing 35,000 pounds, if you got full value for that, that's $100,000. Worth about $3 a pound.
We talked to the mine about it. They've looked at it. I think the question is how long does it stay? Because it takes some infrastructure to run it up to their preset plant is what they were talking about doing, yeah.
But if we had, that's a good question, Courtney. So if we had a more, I don't want to, it wouldn't be a permanent system, but it would be a system that would probably be in there 5 or 10 years, right? But if we were pumping at our usual rate of 5 or 10 years and you had those concentrations, it might make sense to pump it up to the preset plant, right, and recover that.
They have the technology to handle this.
Mhm.
If you fill up a water tank, drive it up there.
Yeah.
Unload it, drive it back. Listen, you don't have to pump it. Just come.
Yeah, well, it's certainly, I mean, part
Well,
of it.
it's parts per billion, not million. It's not 20%, it's 2%.
Oh, it's
Yeah.
2%, okay.
Yeah, 2%. BPP.
Yeah.
Sorry.
I don't want to correct you.
Yeah.
That's still appreciable. There's appreciable copper, zinc, other metals in there, but it was really, I think, they didn't want to do that on a short duration thing like we have so far, but.
So the other thing too, that is that it's not just copper.
Right.
There's a lot
I
of.
saw the sink in there.
Yeah.
And, arsenic and cadmium and, so it's all of the metals. And so if we had to do something else with it, to treat it, it would cost a lot of money. We looked at that. So by MR taking it, it's a benefit to this project. It made this project.
It's going in their process, so I guess, I don't know if you ever could put a number on that. There's some probably, benefit in there somewhere, but it's.
Yeah, I would say in my experience, so we have that estimate of $2.5 million to construct this interim system with wells.
Yeah.
But you would probably have to triple or quadruple that number if you had to treat that water. Right? And then there would be huge ongoing O&M costs on that. So I would think that, by MR taking it, we don't have to, and if they can recover from it, great, but it's really a huge savings for the project and the system. Triple.
So you're gonna have to pump this water for perpetuity. I mean, it's gonna.
Oh, do you want to give him the microphone?
No,
Yeah. Sorry.
Pat,
I guess my question is that, how long are we gonna have to pump the water perpetuity?
no, Bill, that's a good question. I mean, we removed the source of the groundwater contamination, but it's not like a light switch. You don't remove the source, and then, so we would expect, predicting how long that would be is, that's sort of fool's gold. I'm not gonna make predictions of time, but we look at this as an interim action. That could be, 5-10 years, it would be driven by concentration, right?
Right.
Concentration drops off, then it's sort of done. But this is the residual of the sources, right? So if we were like a lot of Superfund sites, a lot of ones I've worked on, they don't remove the source and they just do hydraulic control, right? They just control it, but that you pump and treat forever. That's a forever thing. But we feel like we removed all the primary source, so that won't be a necessary component.
Right, then. Go ahead, Des.
sorry, not good at this.
I think that was amazing, and the monitoring that you've done is also amazing. I hope that's going to go on a little bit longer, because I think one would really like to see it declining some more. But with respect to the pumping, obviously the smartest thing to do is to keep that pumping going, because right now you've got a groundwater table or 3 layers of groundwater table that are all full of copper water and zinc and arsenic and whatever else it put in it, that have been spreading there for how many decades? I mean, many decades. And the best way to clean it up fast is to pull it out. I don't, probably pulling it out here where the source was is the smartest thing, but you could also pull it out a little ways down gradient too. And that will clean it up way, way faster. I mean, if you think of how long that groundwater is going to take to flow out to the Silverbow Creek and the Clark Fork. Well, no, but that's when the first stuff gets there, but it's now filled in all the little holes in the porosity in that aquifer. And it's gonna sit there until it either gets flushed out by a lot of clean stuff coming through. And that's not gonna happen very fast, or it can get sort of pulled back. It could also get pulled back downstream. I mean, the more pumping you do, taking it out and giving it somewhere else, but you probably get higher concentrations if you're pumping it out up here. I mean, I don't know. But I mean, the more pumping one does, the sooner that real disaster will get cleaned up.
Yeah, that's a good comment.
Nick?
Nick's got a question. I thought he was standing there.
It's, yeah, so great job, Josh. This is great data and really well done. Some of us in this room might be feeling a little vindicated by this data. Because it wasn't that long ago where people were literally doing the removal of the Parrot tailings would actually make the groundwater quality worse. A lot of you remember that argument. And so one comment, I love lessons learned. And this project, there's been a ton of removals that have been done in Butte, but they've never assessed the impact to groundwater before. This is the first project that's done that. So like John McKee says, it's kind of a big damn deal. And it's a great lessons learned. So, I mean, I hope you guys are planning on presenting this data to somewhere to everyone. But also, I recommend putting a Doubting Thomas statue where the ball field used to be, saying, "Oh, ye of little faith, why not?" Great job.
Thanks, Nick.
Love it. Any other questions? Comments? That's a good comment. We love it.
Thanks. And I do apologize for an engineer presenting a hydrogeology.
Good job.
Nice job.
So you can't treat old engineers new tricks.
That's right.
Yeah, let me,
So I remember one of the first things that Nick did is after we collected some of those samples, they did what they call column tests. And they put the waste in basically a glass cylinder and they ran clean water through the contaminated waste and tried to figure out how many volumes of water they had to push through there before the metals and the waste cleaned up. Nick, what was the answer? Was it 4 volumes?
So it was it turned out to be 6 more volumes, which take around 25.
Okay, I don't know if you heard that online, but it was 4 volumes, which would take about 25 years of the aquifer to flush through that waste to get it cleaned up.
where is it?
Pat, no questions. Sister Mary Jo here. Can you hear me?
Yes, ma'am, go ahead.
Okay, I just have a comment, and my comment is congratulations to Jim Ford and all those involved with the Parrot Tailings project. You have demonstrated that remediation can be done extremely well and will work. And hopefully you will have modeled something for the others who wish to do the Diggings East and the North Side tailings, etc., and figure out what they need to do to make it really a remediation. So I thank you, and I ask you to continue to do such good work for all of us. Thank you, Jim, and all those who are involved with you.
Thank you.
Thank you, Matt.
Thanks, Mary Jo. So we're bringing up the other presentation, so
Any more questions online?
BNRC.
any questions online? Point right here.